Hello everyone, we are final year students, JBIET-EEE department, batch 1. This is our major project. Our major project title is a compact multifunctional power electronic interface for plug-in hybrid electric vehicle using IoT.
So our project consists components like the main components solar, wind blades acts as turbine in water, and dynamos which are connected in series for front of the vehicle, and this is the battery. This force generates the current and stores in the battery, and this is the transformer for stepping down the 230 volts to 12 volts and 5 volts, and this 12 volts is given to the charging circuit and another 5 volts given to the microprocessor, which is acts as the source for interface for voltage sensors and Wi-Fi modulator. These are the voltage sensors of the dynamo, solar, battery and the wind. This is the LCD display where we can monitor the time to time voltage consumed or generated by the vehicle. After overviewing of the components, let the connection be. From beginning, the 230 volts is given to the transformer, and this transformer is stepping down to 12 volts and 5 volts, and this 12 volts is given to the battery where 6 batteries are each of 4 volts are connected in parallel and series. Here if we take, each battery consists of 4 volts and these 3 4 volts are connected in series. As these 2 are parallelly connected in series, has been given parallelly connection, and finally it consumes 12 volts 2 amps of current. And from this battery current has been given to the charging circuit, where here it has been acting as the interface for all the voltage sources from the 4 power generators. As we can see here, the inputs of the battery are given to the charging circuits. As similar to the old battery given to the circuit board, here we can see the generated voltage input as the pin from the four sources here. This gives the solar, wind and the dynamo and the battery. The generated voltage is given here to the charging circuit. It is the rectifier which is used to rectify the generated voltage, and this is the capacitor which filters the rectified current, and these are the resistors for controlling the current flow, and these are the unidirectional diodes which is used for the controlling of the polarity changes varied by the generated current in the generating sources, just as wind blades, solar and dynamos. As we see, these are the connections given from the sources, generating sources, and an interface is being here acting named voltage sensor, which is used to sense the voltage and given input as the microcontroller, which is assigned a task of displaying the voltages on the LCD display, and also a connection given to the and this is the Wi-Fi modulator, which is used to display the power consumption or voltage consumed by the sources, as we see here, which is seen in the graph wise. Here table 1, graph 1 shows the voltage consumed by the wind, dynamo, solar and battery, and this is shown in the application called THINGSPEAK. Let's observe the graph in the THINGSPEAK. Before owning the circuit, let's connect the circuit with the Wi-Fi hotspot. As we can see, the name, as I stated the name of the project as project 6324 and password. This password and name has been fed in the Wi-Fi modular so that it can be automatically connected to the device for mobile. Now owning the circuit, as we can see the LED screen, solar, wind, dynamo, battery. And coming to the Wi-Fi, we can see one device has been connected named as ESP-B4. This ESP-B4 B7 is the programmed processor, where in the program we have been saving the username and password of the THINGSPEAK. After device has been connected, let's see the graphs. We can see the wind W is been varying from 0.8, 1.9, 1.1, 1.5 and 1.9. Also we can observe the battery as 11.8 volts, and in the graphs, as we observe, this is the solar, where the lies existing is been a lot, so the increase we can see solar. And in dynamos, due to no rotation in the vehicle and sudden fall of the dynamos, we can observe. And in wind, as we rotate the wind blades, it's been increased slightly. No major generation of power. We can see a straight line which is of 11.8 battery generation or consumption. A sudden fall of dynamo. Now let's see the working of the vehicle so that the wheels start rotating. As I said, the front two are acting as the dynamos, which are connected in series. To operate the vehicle, these are the switches we use. As we see in the indication, 2 lines and single line. We can, by operating, we will explain.
If we press two switches at a time and move front and two switches back, move back direction, and right side, right switch. If we press front, it moves right front, and it moves right back when we press the switch. And left side switch, if we press, it moves left side, and if we move back.
Here we can see as the vehicle starts working or moving. Here we can observe the increasing of the dynamos power generated. In the similar way, as we see, solar also fluctuates. As we see here, voltage generated as 11.8 in the beginning, and in the ending also it seems as 11.8. As it's seeing as 11.8 volts because it's the maximum voltage generation is 12 volts. Due to it is the domestic purpose. As here we see in the data in the graph wise. To export the data, here we have an option, data import and export. By clicking data import and export, page will be displayed, and here by clicking the download, we can download the data. We can download the file, and here we can see downloaded file and open. I am using WPS Office. Here these are the dates and the data recorded by the IoT, that is THINGSPEAK, which has been given as in Excel sheet. These are the dates. These are the entry dates and time where the readings has been taken, when and here field 1 denotes solar, field 2 denotes wind, dynamo and battery.